Question 3, Part A. In the diagram, A, B and C are the points 1, 4, 5, -4 and -3, -1 respectively. The line AB meets the y-axis at D. Part 1. Show that the equation of the line AB is 2x plus y minus 6 equals 0. To find the equation of a line or an interval passing through 2 points, first we need to find the slope or the gradient of that interval. Then, using a known point on that interval, in this case either point A or point B, we can use the point gradient formula to come up with the equation that we require. Now, the gradient of interval AB is found by change in y divided by change in x. Now, I've sketched interval AB for visual reference, and I've sketched the right angle triangle around it as well. Now, the change in y is found by -4 minus 4, so it's the difference between -4 and 4, taking into account the direction of the line, and that gives us -8. And the change in x is the difference between 5 and 1, from left to right. 5 minus 1 is equal to 4, so the gradient of AB is -8 divided by 4, which equals -2. Now I'm going to use point A with coordinates 1, 4 with the point gradient formula and the gradient that we just found to find the gradient of the line through AB. So y minus y1 is equal to m times x minus x1 in brackets. Now the x1 is the x coordinate of point A, which is 1. The y1 is the y coordinate of point A, which is 4. And the m is the gradient of the line or the interval through AB, which is -2. So y minus 4 is equal to -2 times x minus 1 in brackets. Expanding the brackets on the right-hand side, we get y minus 4 is equal to -2x plus 2. We need the equation in general form, which means the coefficient of x has to be positive. So I'm going to move the terms on the right-hand side over to the left-hand side and combine the like terms. And we get 2x plus y minus 6 equals 0 as required. Part 2. Find the coordinates of the point D. The point D lies on the line through AB. In other words, the coordinates of D satisfies the equation 2x plus y minus 6 equals 0. Now the x coordinate of D is 0, since D lies on the y-axis. In other words, it's a y-intercept. So I'm going to let x equal 0 in the equation of AB and then solve for y. So from the equation of AB, I'm going to let x equal 0. So we have 2 times 0 plus y minus 6 equals 0. Now 2 times 0 is 0. So the equation simplifies to y minus 6 equals 0. Solving for y, we get y is equal to 6. Therefore, the coordinates of D are 0, 6. The perpendicular distance D of the point P with coordinates x1, y1 from the line AX plus BY plus C equals 0 is given by the formula D equals the absolute value of AX1 plus BY1 plus C over the square root of A squared plus B squared. Use the perpendicular distance formula to find the perpendicular distance of the point C from the line AB. Using the perpendicular distance formula, the perpendicular distance of point C with coordinates -3, -1 from the line AB with equation 2x plus y minus 6 equals 0 is given by D equals the absolute value of 2 times -3 plus -1 minus 6 over the square root of -2 in bracket squared plus 1 squared, which equals 13 over the square root of 5. Therefore, the perpendicular distance of point C from the line AB is 13 over the square root of 5 units. Part 4. Hence or otherwise, find the area of the triangle ADC. The interval AD represents the base of triangle ADC. Now I've sketched triangle ADC for visual reference. So here's the interval AD, and here's the perpendicular distance of the point C from the line through AB, and that represents the perpendicular height of triangle ADC. Now we need the length of interval AD, so using the distance formula, AD squared is equal to 1 minus 0 in bracket squared plus 4 minus 6 in bracket squared. That's x2 minus x1 in bracket squared plus y2 minus y1 in bracket squared. So AD squared is equal to 1 plus negative 2 in bracket squared, which equals 5. Taking the square root of 5 to find the length of AD, since we have AD squared, we need to take the square root of that. We get AD is equal to the square root of 5 units. Now the area of triangle ADC is equal to half times the base times the perpendicular height, and that equals half times the square root of 5 times 13 over the square root of 5, which we found in part 3, which equals 13 over 2 square units.